Hey, how's it going? In this video, we're going to quickly talk about end-to-end type safety with your REST APIs. This could be with NestJS, NextJS, or even Express. Let me first try to explain what end-to-end type safety even means. So on the left side here, you can see that we have some Swagger docs for a really basic API. We've got, like half a CRUD. We've got get posts. You can create a post on /posts, and you can also get by ID. And this also documents the response shapes of your API. So like you get back an array that has a shape like this, you get status code 200. On the post, you get just an object and status code 201. And on the get by ID, you get 200 and a 404. So the response there differs a little bit based on whether or not the call actually succeeds on finding your post. On the right side here, you can see we have a client of sorts. Like it could be like a React API, it could be Angular, whatever. But you can see that it's importing this contract. We'll talk about what that is in a little bit. But we're creating a client off of that contract. Then if we take a look at the IntelliSense for the client, you can see that it actually has methods. So RPC-like methods for each of the endpoints that we had on the left side here. And you can see on the bottom here, we have a get post. And again, if I hover over that, it tells me that it requires a param of ID, which is exactly what we need on the left side here for get by ID. Now let's take a look at the types of the thing that it returns. You can see that status, it actually already knows that it can only be 200 or 404, just like our documentation shows. And the body also has that union between the successful response versus the 404 message object, right? So it's a TypeScript representation of the documentation that we have on the left. And in fact, this entire documentation was also automatically generated off of this contract, right? So I hope you're starting to see what I'm trying to explain here. We have this concept of a contract that basically our API adheres to. It's saying it needs to return these things in this type of this shape. And then on the client, we can pull in that contract and create basically a very easy to call method that has all of the types that we need. And the amazing part of this is, for example, if I were to do something like if status is 404 and let's just return the body here, guess what the type of that body is? It's just a message. Like there's a connection between like what we documented, the status code, and the response. Right, and because we're returning here, that means we've slimmed down the type down here, and the body in this case only has the successful response, right? So if we delete this, we get back the union. So there's a connection there between the method you're calling, what are the responses that it can get back, what are the statuses, and also what is the shape of the body per status. All right, so hopefully you're seeing how awesome this is, and I'll show you how to set this up in just a second on a NestJS API. Now you might be watching this and asking yourself, wait, isn't this, I've seen this before, is this just TRPC? And it's not. You can see that we're using TS REST, and there's a very clear distinction between this solution and that solution, which is that it's still very much REST first. What do I mean by that? So you can see if we change our URL on the left to be /posts, it still very much functions just like any other REST API. Like you can still use your old school HTTP GET with /posts. So the distinction here is that although you have this typesafe client, it doesn't block your API from being used by other clients who might not for some reason have access to this contract. And like I said, the documentation that we showed earlier is fully generated from this contract. So again, you still get benefits of documentation for free. All right, so let me show you how to set this up so that you can do it on your API, and it is incrementally adaptable, as you can see here. So you can try it out on like a single route if you wanted to. So at a super high level, the steps are really simple actually. So first you got to install TS REST itself and Zod optionally. Once you have TS REST and Zod installed, at this point what you need to do is create what we were calling earlier a contract, which is basically a representation of your API. Let's take a quick look at what that means. So you can see that we're defining a router, and within that we're defining keys for each of the individual REST APIs that we have. We define what method it is, what path it is, and the responses that you can get. And you can see that you define the status code, and then you provide some kind of schema. Now the schema, you can see that we're using Zod here. We have a basic schema that represents our post. It just has an ID, a title, and a description. Now you don't necessarily need to use Zod. You can see that you can provide generics to see that type. However, you might know that Zod is very useful for runtime validations as well. So for example, when you create a schema like this, you not only can use that to validate a request body that's coming in, you can also infer a type off of that, so you'll get the TypeScript type for free anyways, right? So that's why we're using Zod here. But moving forward, you can see that we're also defining summary. So there's a couple fields here that you can define for documentation purposes. So for example, I believe you can also do description here, and that's what helps add some of this text. You can see that we have get posts here, and then I did the description showing up here, right? So there's a couple things you can provide for documentation purposes, and I'll show you how to generate the Swagger doc using that contract, by the way. But let's just keep going for now. There's also this concept of strict status codes. That just means that you're really restricting the type to be just the ones that you define here. So it's like very as type safe as you could possibly make it. So that's optional, because in a real API you can also have like technically a status 500, right, if it fails. So it starts out a little bit more flexible, but you can make it more strict if you wanted that maximum type safety. And the rest of the code here is pretty similar, right? We've got another key for another route. Same thing, we've got post, path, responses, different status code. We've got a similar schema here, but this one has a body which you can see is just the title and the description, because typically the ID we would generate server side. And actually I think I meant to use this create post schema here, which omits the ID. We can probably take that and replace this. And then same thing for our get post. This is what you saw earlier. We got a get, we got a path, and it already somehow extracts that it requires an ID, as you saw from the params, just from having this pattern in the URL path here. And then same thing, we've got responses, and you saw that we can only have either 200 or a 404, right? So this code is pretty simple, right? Again, we're defining init contract, and then within that we define our stuff. Now where do we go from here? We can then take this contract and apply it to our server side, our API. Now I need to show you the documentation for this, because there has been some recent changes, so I want to make sure you don't get confused. So the main package for NestJS that you need to care about is tsrest/nest. Now there are two different syntaxes that you can use. There is the single handler approach, which kind of looks like your old school Nest controllers, where you have one-to-one handlers per API method. And this is really useful if you're trying to incrementally adopt tsrest for one method at a time, so you can do it. This is probably really useful for you. However, if you want ultimate type safety, you want to use the multi-handler approach, where you only have one decorator, a single handler, and then a bunch of nested handlers, right? So this is if you want to make sure your methods are always returning the correct response types. So if we take a look at the code that I wrote for this demo, you'll see that I did use the multi-handler. So you can see here I have a post controller, dependency injected post service in the constructor. We're importing our contract, and then we provide that within this decorator, the tsrest handler. And then there's just a little wrapper function here that really could be called anything, I think. But within that, it's returning tsrest handler, which is like wrapping all of your methods basically, which also takes in contract, and then within that defines your individual methods. Now it does look a little bit redundant because we're already passing contract here and all this here, so I'm not really sure why that's required. But the rest of the syntax is dead simple. You can see that we're implementing get posts because our contract requires it, right? So our contract here says on the right side we need a get posts. If I were to change this to get post X, you can see that I get red squiggly on the right side. And if we bring in our client on the right side too, actually, you should see that if we were using get posts here originally, that's also gonna get a red squiggly, right? And if I correct this to get posts again, it removes the red squigglies on the left and right side. right? So that's really what we mean by end-to-end type safety. There is this contract that both the server and the client adheres to, right? So let's talk about this a little bit more. Our contract says that this is going to be a get with a given path, and we don't even need to define that on the controller. The contract already handles that for us. So that's one thing that's a little bit different, is that, you know, in the typical NestJS fashion, you would define these using a decorator, right? Like you would have like a get, and then you might have the path in there like this for your handler. In this case, it moves that away to the contract. So on the controller side, all you need to worry about is actually the implementation. So it's saying that if we didn't have this, it's going to give us an error because it says this needs to implement get posts. You can also see that if I'm somehow not returning the correct response shapes, it's going to tell me that. For example, if I just return a body like this, it's going to tell me that the types of body is not compatible with what I'm trying to return, right? So it's type safe. That's what we're trying to achieve here, right? So it absolutely needs to be an array that has a shape of post schema. And within this post service, by the way, there's really not much to it. I'm just have an array of posts. I'm importing that same type that I have from the contract that I inferred over here. And then, you know, I'm just returning from an array and finding one from that and create. I'm just inserting. So pretty basic code. But again, just going through the rest of this, we've got the get post. Same thing. Need to return the specific object. And then you can see that we talked about how one of the optional responses is a 404. Again, same thing. If the contract says that I have to return a 404, but I don't do that, right, it's going to inform me of that. It's going to give me red swigglies and saying you're missing something here. So that is one other different thing that you have to call out, is that we provide the status via the response object, which is a little bit different than your typical NestJS API, where usually the status is sort of like figured out for you. Like in Nest, usually if you do a post, it's automatically a 201, whereas here you do need to specify that it's a 201. So that's not terrible, but just something to be aware of. And then finally, we got create post. Same thing, we create a post. There's a body here that's already typed, right? There's no other decorator that I need to bring in to get the type of this. It's already typed because it's pulling that from the contract, and it says the body is a create post schema, right? So the type of this body is just inferred for me. I don't have to think about it. And that is the same thing, by the way, for the client side. If I were to do client.create post, it's going to tell me that there's an args in here that requires a body. And you can see that the IntelliSense says that the body has description and title, right? So again, that one contract is informing end to end both what the server side needs to implement, the types that it requires, as well as client side, what does that look like. And I didn't have to manually create types that I have to share between these two applications. I just needed to create a single schema with everything that it needs, and it forms basically your entire application of what the types are. Everything is just inferred. I think that's a really, really nice developer experience. And that's really honestly the code server side in a nutshell. There's really not much to know or set up. You just import your contract, you import your handlers, and just structure it in a way, again either using the singular handler approach, which just, it's the same thing, but it just divides it in individual handlers like this, right? Or the multi-handler, which you just saw in our own code. Now you might be wondering, okay, how does this work in a real application? Well, the way I see it is you might use this in perhaps a monorepo. So I made a video about creating a React and NestJS monorepo in the channel if you want to check it out. But that's an example where both the server and the client are in the same code base. That means I can just put the contract somewhere shared that both of them can import. And then, like my example client here, it just needs to implement the contract, initialize the client for there, and then just call it. And by the way, if you're using React for the client, there's actually also support for React Query. So it's very much close to something you expect from like TRPC. So instead of the usual init client, you would use init query client. And if you've used React Query before, you can just, it's the same exact syntax of just using use query and use mutation, except you're accessing it from that client object that you created. And all of these things, again, should have type parameters, type body. So this is a really cool integration. If you want to see this in its own standalone video, let me know in the comments. I wasn't sure if it was maybe too much to cover, but I'm just giving a quick overview here. And then I did mention they also have support for Next. So if you were trying to use TRPC for the app router on NextJS and found that, oh, you can't use that right now, you can use TS REST in the app router from my understanding. And then there's also support for Fastify and Express. And then I kind of forgot to cover this, but there is support for Open API. So if we go back to our NestJS server code, if I go to main, you can see that we also import a contract in here, and then they expose a generate open API from tsrest/open API. We can provide some config options in there, and then we just do the usual Swagger module that's set up from NestJS Swagger, and that's it. That's how this entire documentation is generated. So again, if you can picture in your head, we have like a contract that is effectively powering our server documentation, and our client, and they're all being synced together via this one contract, which in my opinion is a really nice experience, especially if you're into API first design, where typically you would be defining the contract anyways, right? So this contract becomes your single source of truth. Now, if you weren't working on a monorepo though, I could see this maybe being stored in a library, and then you can just install that library in both your server and client side, and then they just get all the types for free. Anyways, that's it for me today. This is a pattern that I'm personally pretty excited about. It's something I want to try in some of my newer projects. Let me know what you think of this solution. Is it something you'd try, or does it not look good to you? Let me know. I'd love to know. Anyways, hopefully you enjoyed the video, and I hope to see you in the next one.